Righto, Eg13. So we've now met how to differentiate e to the x, and the first one that they want us to differentiate is y equals 3e to the x. And when we differentiate y equals 3e to the x e to the x, it just remains as it is, so we end up with dy dx equals 3e to the x. It's unchanged. So that's it, it's done. When we differentiate e to the 2x, however, this is where we need to spot that we've got this 2x function inside the e to the x function. So we've got a chain rule. Okay, so let's flag that up, that we've got a chain rule. And if you think back to the way that we were doing this in class, I'd say cover up your embedded function. So dy dx equals e to the finger. When you differentiate e, you get e. So e to the finger becomes e to the finger, and the finger bit is the 2x, and we have to multiply that by the differential of what we'd covered up. So we differentiate 2x, we get 2. So using the chain rule, y dy dx will be 2e to the 2x. C. Y equals e to the x squared. Well, same again, we've got the x squared function embedded in the e to the power of function. So once again, this is the chain rule. Cover up the embedded function. E to the finger, when you differentiate it, you get e to the finger. Multiplied by the differential of what you covered up. So when you differentiate x squared, you get 2x. So the differential of e to the x squared is 2x e to the x squared. D. Y equals 2x cubed e to the minus x. Well, I'll tuck that up so we've got space. So this time I've got a product. I've got the 2x cubed being multiplied by the e to the minus x. So we're going to start off with the product rule. With the product rule, we let u equal the first part of the product. So that would be 2x cubed, and v be the second part of the product, which is e to the minus x. When we differentiate u with respect to x, we get 6x squared. Now here we've got an embedded function again, so I've got a chain rule tucked away inside this product rule. So when I differentiate v, I get e to the finger multiplied by what you get when you differentiate what you covered up, which will be minus 1. So that equals minus e to the minus x. And then the product rule, I'll write it down just so that you can remember. And as I've said to you in class, the more times you write this, the more chance you've got remembering it. Okay, so u dv dx plus v du dx. So u is 2x cubed times dv dx, which is minus e to the minus x, plus v, which is e to the minus x, times 6x squared. Now, if I tidy this up a little bit, that's going to be positive, that's got a minus, so I'm going to write this as 6x squared e to the minus x minus 2x cubed e to the minus x. So I've reversed them to make the negative the second term, just out of neatness. Now At this stage, we can go hunting common factors. I can see I have 2 as a common factor. I can see I've got x squared as a common factor because that's the highest power that will go into both parts of the expression. And I've also got e to the minus x as a common factor. So in this first term, all that's going to be left is 3. Check that by multiplying it back out. 3 2s is 6, x squared e to the minus x. And in the second term, the 2 is gone, the x squared has come out, leaving me an x e to the minus x. So when you differentiate e, where are we, d, 2x cubed e to the minus x, that's the expression you get. When you're working through the exercise, what I suggest you do is once you've done your differentiation, you've built your chain rule or your quotient rule or your product rule, have a look at the answer to see what you're aiming for, to see how much manipulation you need to do. I mean, that isn't incorrect, but that is a better looking end product because you factorized. So that's D. And then we've got E. Y equals x e to the x. So clearly we've got a division going on there, or a fraction. So it's going to be a quotient rule. That's u, that's v. So we let u equal x, v equal e to the x. We differentiate u with respect to x, we get 1. We differentiate v, we get e to the x. So the quotient rule, write it out, v du dx minus u dv dx all over v squared. So for us, v is e to the x. Du dx is x minus u, which is x, times dv dx, which is e to the x. Sorry about that. Right, I've just gone wrong there, distracted by my phone. So v du dx is e to the x times 1 minus x dv dx is that all over v squared, which is e to the x all squared. So with that one, I can take e to the x out as a common factor on top, 1 minus x, and underneath there I'm going to raise a power to a power, so you multiply them, so you get e to the 2x. But what you'll see then is that this will cancel, because you basically got e to the x times e to the x down there. So your final answer will be, we could write it as 1 minus x over e to the x, or you could write it as e to the minus x 1 minus x. It means the same thing, it doesn't matter. And again, the majority of the marks for that question would be to getting to these parts here, and then it's just a finishing off then. And if it's not a show that question, you know, you don't need to go into places you may make mistakes. So that's EG1. I've put for exercise 8.5 a must, should, could, because there are some quite challenging questions embedded in here. Okay, so certainly do question 1 A through to K, and question 2 and question 4. If you want more practice with a few more challenging questions, then L and M on question 1 are good to do, along with question 5, and then could question 1N is a toughie, as is question 6 and question 7. But my worked solutions are all online as well, so if you do fancy a challenge and you can follow what I've done, that's great. Otherwise, let me know and I'll do a video clip of me working through anything you're unhappy with.